Newcomers to JavaScript often struggle with its asynchronous nature, particularly if they're coming from another programming language that doesn't have callbacks. The struggle is intensified when they hear about promises because they're told that promises make things better, but they're not necessarily simple. Before digging into how promises can help, let's take a minute to look at a fairly common problem, fetching data, and how the fact that it's asynchronous throws a wrench into the whole system. The code you see on the screen makes two separate HTTP requests. This block of code might not be something you see every day, so let's take a second to walk through the high points. It starts by creating a new XML HTTP request. This object allows us to make requests against an API. It specifies the path of the request in the open function. It then has an onload function that you can think of as success. Finally, it has a send function. That is, the entire block is set up and then the request is actually sent. You'll notice there are actually two XHR requests. The first request is to the order statuses endpoint, and the second request is to the orders endpoint. Once the data comes back from the orders call, which can be seen in the onload function of the XHR request, it looks up the order status for that particular order in the list of order statuses that was returned above. Switching over to my browser, I can run the code that you just saw. When I click the race condition, the results in the bordered area below will update. You can see that the value comes back as undefined. That could be for a variety of reasons, including a bug in the code when we look up our status. But there's not a bug. Take a look at the console. What do you see? Do you notice that the /orders request comes back before the /order statuses request? This is ultimately what produced the undefined result. Going back into the code, you can see that we try to look up the order status description by comparing the current order status ID against a list of status IDs that we already fetched. But if the order status call returns after the orders call, then our list is empty. And this is what produces the undefined response in our application. Code like this is not unusual when people first learn JavaScript. Most people have written code like this, and they've seen it fail, just like this. We can fix this code so that the correct value returns and displays in our results area. All we have to do is move a little bit of code around. We'll see what code we have to move and where it has to go next. Dealing with APIs can lead to uncertainty. In the previous clip, we weren't sure we actually had the data we needed when we needed it. In this clip, we'll see a technique that we can use to ensure that we have all of the data we need before we use it. Returning to our demo page, we can perform roughly the same call, but this time we can ensure that we have our order statuses defined before we try to access them. Clicking the callback button will take roughly 1.5 seconds, and then the data on the screen updates to show that our order status is in process. Looking again at the console, we can see that the order of our API results is reversed. With this button, the order statuses are returned before the order's data is returned. This ensures we have our data, but how did we ensure that? Take a look at the code on the screen. The code itself is quite similar to the code you saw in the last clip. Once again, we have an XHR that is fetching the order statuses and a second XHR that is fetching the orders. There's a slight difference though. Did you see it? It's that our XHR2 is defined inside the XHR onload function. That is, we're waiting until the data of our first call came back before we even attempt to make our second call. By doing this, we ensured that we have all the data that we need for our second API request. However, it comes at a cost. Now our second call is buried inside the success of our first call. What problems could be caused by nesting functions in this manner? In the next clip, I'll tell you about two problems that you can run into if you nest your code this way. As we saw in the last clip, one way to solve the race condition problem is to use callbacks and functions inside of other functions. While solving this one problem, we've introduced another problem, the callback pyramid of doom. According to Wikipedia, a callback pyramid of doom is a common problem that arises when a program uses many levels of nested indentation to control access to a function. But why is it called the callback pyramid of doom? Well, let's start by looking at a simplified example. The code on the screen is an example of code that could be called a pyramid of doom. It gets this name from the indentation on the left. If you tilt your head just right, it looks like a pyramid. This is the type of code that you might see in JavaScript when you need to make sure that A runs before B, and B runs before C, and C runs before D. But what makes this a pyramid of doom and not just a pyramid? That is, why is this bad? The first reason is that it makes dirtier code and exposes you to more errors. Let's revisit the code from earlier in the module with a slight tweak. This time, instead of just getting 2 pieces of data from the API, it's getting 4. And each one is nested inside of the previous one. There's a lot going on here. Even though most of it's similar, you still need to process what's happening every time you read it. And in fact, there's actually a bug in this code. Did you see it? Inside the XHR3 onLoad function, instead of parsing the results that came back, you're parsing the results that came back on XHR2. It's a simple mistake to be sure, and it's one that when you see it in your code, you'd likely chide yourself for being so careless. But it's also a common mistake. In fact, in preparation for this course, I did this exact thing in some of the sample code. Don't worry though, I fixed it so that you won't be seeing this error again in this course. Another problem with pyramiding code like this is, how do you handle errors? If XHR3 returned a 500 from the server, then XHR4 wouldn't be called and the one error function of XHR3 would get called. But it's inside the onLoad of XHR2, so what would happen? If you said you should handle the onError case, you're right, but that can make your code even messier now. You now have a lot more code in your onLoad functions and you're making the first problem even worse. But beyond that, XHR2 and XHR1 calls were successful, so their onError functions aren't called. And now you're handling errors inside of a success function, which can lead to another series of messy decisions in how you write your code. So how can we solve this problem without introducing a new problem? How can we write code so that it executes in order without massive nesting of functions? We'll learn how next. As we've seen, nesting callbacks can lead to messy code. How can we get the benefits of nesting without the messiness of nesting? The answer, as you might have guessed, is promises. But what is a promise? According to Mozilla, a promise is an object that represents the eventual completion, or failure, of an asynchronous operation and its resulting value. Right off the bat, we see that it's an object that helps with an asynchronous operation, which is what we've been dealing with. It also tells us that it represents the eventual completion. That is, when a promise is called, it may or may not have a value. The value could come instantly, or it could come at some time in the future, like our order statuses call that takes 1.5 seconds. Another way to think of it is that promises allow developers to write asynchronous code in a more clear and less error-prone manner. And that was a big part of my motivation when I first learned promises. Even though the concepts were not intuitive at first, I persisted because I wanted my JavaScript code to be more readable. A promise can have 3 states. First, pending. This is the initial state. When you first create a promise, it's in the pending state. Since we're talking a lot about API calls, well, the call is happening, the promise is pending. If you remember the order statuses call that took 1.5 seconds to respond, a promise would have been in the pending state for the entire 1.5 seconds. Second, fulfilled. A promise moves from the pending to the fulfilled state when the asynchronous call has completed successfully. When a promise is fulfilled, it will return a single value. For example, a specific order from an API. The third and final state is rejected. A promise moves from the pending to the rejected state when the asynchronous call has failed. When a promise is rejected, it returns a reason why it was rejected, similar to the catch function in a try-catch block. There are a couple other terms that you might hear with promises. You might hear someone say that a promise is settled or resolved. Both of these are referring to the same state. Whenever someone says a promise is settled or resolved, they mean that that promise is now in either the fulfilled or rejected state. That is, it means that a promise is no longer pending. One quick note while we're talking about the definition of promises. If you're coming from another language to JavaScript, you might already be familiar with a concept called promises. In some languages, these promises are a term used for lazy evaluation of code. In JavaScript, that is not the case. JavaScript promises are eagerly evaluated. Throughout the rest of the course, we'll see how we can get the values out of a promise, but it's important to note that promises do not wait for us to request the value before they execute. With that brief theory of promises, you're probably ready to start seeing them in practice. There's one quick step we need to do first, and I'll walk you through that next. Are you starting to see the types of problems that promises are trying to address? Are you ready to get into some code and see what's actually going on? If so, great. Let's take a minute or two and make sure that we're all on the same page with a sample project. For this course, we'll be accessing an API used by Carved Rock Fitness. They're an online sporting goods retailer. Their API allows them to create, track, and ship orders out to their customers. Their API consists of a few key objects. First of all, addresses. Then products or items. Next, orders. And of course, users. There's also a couple metadata entities. Specifically, there's item categories and order statuses. This is but a small part of their API, but using these entities, we'll be able to check on the status of an order or determine where the order has been shipped to. In order to run the API, we first need to get the code. Start by cloning the GitHub repo for this project. And while you're on that GitHub page, expand the list of branches. In addition to the master branch, there's 4 other branches. There's consuming promises, creating promises, iterating, and understanding promises. Those 4 branches line up with the modules of this course. Each branch is the code that you need to see the functionality of the module. There's 2 ways that you can use this. First, you can start with the previous module's branch and enter code as we go along. I hope this is the path you choose because typing the code in will help to build some kind of muscle memory, so to speak, of how to solve some of the problems. And if you run into a problem that you can't get the demo to work, you always have that safety net of just checking out the correct branch and you're back up and running. The second option is to watch the course, and when it's time to run the demos, you check out the branch for the current module and execute that code. The choice, of course, is yours. Now that you've cloned the code, go ahead and open it up in your IDE. I'll be using VS Code, but any IDE you're familiar with will work. Make sure you're on the Understanding Promises branch. There's a couple things to notice in this project. First, this project is built on top of JSON server. This gives us the ability to run an API locally without needing to set up a database. The data for this is located in the data/db.json file. Since JSON Server is an external dependency, you will need to run npm install before the project will work. Next, notice that there's a series of .html files. Specifically, there's consuming, creating, index, iterating, and understanding. The index.html file is the root of the website, and as you might guess by now, the other files are tied to specific modules. You will not need to edit any of the HTML files throughout this course. They're set up and ready for you to run. After all, this is a course on asynchronous JavaScript programming, not HTML coding. That leads us to the last thing to note. In the source folder, there are 5 MJS files. There's one for each of the modules, and a 5th one named results.mjs. This file is a helper file that will display some information on the screen for us. As with the HTML files, you will not need to modify this file during the course. Open up the understanding.mjs file. Here you can see the code that you've already seen in this module. If you open up consuming.mjs, which is the next module, you can see 5 empty functions. You'll be coding the body of these functions as we go throughout the course. Speaking of which, are you ready to start coding and seeing how promises can help you in your JavaScript coding? We'll jump right in the next module.